Okay, so we left it. Where do we leave it? So if I run this, I think we left it to just basically the neural network with an input shape of 520 because it was, yeah, okay, so that was working, but then this is what's not, like, this is what I didn't like. So essentially, input shape, and then, yeah, so I'm giving it one thing and it's printing that thing. So, okay, input encoded, output, yeah, okay, so that's fine. So 75, the 75 thing. So we'll take, of course, a different batch for training, a smaller batch for training, and then essentially it's always 5 words. No, yes, 5 words, and then dimensionality 20, 5 words, yeah. And then the output is just basically that's wrong as well. Output reference. Oh yeah, it's 75. Of course, it's 75 single words exactly. And then we are doing this, instantiating this basic neural network with the input shape, and then we're just doing. So I think that just instantiates it, right? So it initializes the stuff. Okay, cool. And then basically, the only thing that I just did is I just run a forward pass, which is just pretending that using whatever the model it is and assuming that just like it's the model, right? So we're not training it, and then we're not training, like we haven't trained it at all, and then basically do a forward pass, and that what I want is that the forward pass gives me the an array of this thing, of this size, like with just a probability distribution. You know what I mean? I want that, but instead I'm getting a so the forward pass returns. It does whatever dot matrix, like softmax, right, which kind of gives you the probability between 0 and 1. But then what I want is I don't want I don't want these. So ideally, I'm not so sure the forward pass is doing the right thing. You know what I mean? Like, we need to fix that, because what is V2? What is this even used for? The backward pass? Why are we returning A2? So in the forward, so what I want is the forward pass, right? So maybe that's not, what is the forward pass supposed to do really? So what is the forward pass supposed to return? Neural network. Not explain code. I want default. I suppose I return the output, right? Okay. But I want it's currently returning something of shape 5 output size, but I really just want to have an array of the sort of the of the language, of the English vocabulary, right? Of the size of English vocabulary with probabilities and its values. Can I stop it? I think stop generation, and I want the default mode. So to modify the forward pass to return an array of the size of the public device, to modify the forward method by adding an extra step. Okay, so so what is it currently doing? So it's currently doing dot tangent and then this dot thing here. So yeah, but why are you now not updating A2? What is even A2? Like it's not even something that is initialized here. That's what's kind of sketchy about this stuff. Or not sketchy, but that's what makes it it's funny. It's like a different paradigm, right? It's like a different way of progress. It's like you can't really fully trust that thing, but it gives you something to start. I think it really kind of helps with like that blank page problem of like, okay, where do I start, right? Like you've got like a syntax. Sometimes you're not like familiar with the syntax. You're not like you don't really even know how to start coding. That kind of gives you a sort of a starting point that you can work from. So, the output. So so let's see. But that's still, I think that's still not gonna give me what I want. Z2. That's still not what it. I think it's still 5. It's still 5, and this kind of it's still. This still returns something of shape 5 and output size. Because we're doing so there's a dot product in here. There's 2 dot products. So can you explain me what the 2 dot products inside the forward function do, and how does the next method play into the calculation? So math performs the forward pass on it takes an input x which has shape batch size input shape. The problem is it thinks it's batch size. That's the problem. The problem is that it thinks it's a batch size. First, the input tensor x is multiplied with a weight matrix with a product, and the tan activation function it's an activation function. Okay, multiplied with a weight matrix is a dot product operation. Then the bias is added. The result is stored. Yeah, the problem is it thinks it's a batch. The problem is that it thinks it's a batch, and it's not. It's really maybe it's just maybe I should maybe I should just put all those sort of words together into one array. You know what I mean? So my input is not 5, and you know what I mean? I think I should just flatten my input. Shouldn't I? Shouldn't I just flatten my input? I think so. I think that will maybe... This I don't know, like okay, so currently I have, I think I should flatten it, man. Because that's just by design. That's just by design. It assumes you've got an array and you're multiplying it with a matrix. That's why it's not working. So do neural networks work with with like basically with tensors as inputs, or does any given input need to be flattened into an array? They can work with tensors, multidimensional arrays that can represent complex data in the code provided. Not explain code. I won't default. Neural networks can work with tensor inputs. In fact, many neural libraries and frameworks, including popular ones like TensorFlow and PyTorch, handle input as tensors. A tensor is a multidimensional array that generalizes the concept of scalars, vectors. Inputs often represented as tensors to capture multidimensional nature of the data. For example, an image processing task, inputs are typically represented as 3D tensors. Yeah, okay, but this like the batch size, right? The dimensions of the image. So there's no need to flat inputs into 1D array before passing them into a neural network. The network will process them directly. Will it though? That's what I'm not. If you're using just dot product, you know what I mean? Like if what you have is like you treat all your layers as a matrix, right? But then if you treat, but then internally, if you treat all the weights as a matrix, you do expect the input layer to be an array, don't you? It should be. I won't default. Yes, in a network, the weights are typically represented as matrices. Each layer in the neural network has its own weight matrix. To perform the maximum multiplication operation between the input and the weight matrix, the input is said to be a 1D array, or a flattened version of the input. Yeah, that's what I thought. That's what I thought, but I'm not so sure if I can trust that answer. But it kind of just makes sense. It's just if you treat your weights as a matrix, right? You like just by definition the input must be an array, like must be a tensor of one-dimensional length, because otherwise it's just you're not like the concept is not going to work. The concept of multiplying an array by the matrix is so that you sort of apply the weights, right? You apply those weights. It's everything interconnected, right? So you apply those weights. I don't know. I think I'll go with that. So I think probably in here, I think we in the initialization we just have to. That's what I don't like. I think basically input shape 1, that's wrong. Should be input shape. You know what I mean? Like here it's just randomizing. It's taking the second dimension, but just hiding the batch. You know what I mean? It should just take. You know what it should do? I think it should just be input size, basically. And it was already like that. I remember that I actually, I think I told it to change it. So it should just be input size, and then it should be just these times the hidden size. Yeah, because you want, like, the hidden size is the size of the hidden layer, I guess. The first layer, you just want it to be as big as, yeah, it's just the input size, exactly. And here this needs to be the flattened thing already. Input size, hidden size, hidden size, hidden size, output size, output size. Yes, and I think what I should do here is basically flatten. So input size is essentially 5 by 20. Well, input size is, should I just input encoded shape, right? So input encoded. I think I should just hit input encoded. Yeah, so it's 5 by, I'm just hard, this is hard coded, but I will not hard code it later, I guess. That's fine. Input size, input size. But then what I should do here is flatten. So Ghostwriter, how to flatten this tensor. Edit code, use reshape. Flatten input, reshape. So what does reshape -1 do? What does shape -1 do? What's the reshape signature? So additional data, when you press on the parameter for the reshape function, it means that the size of the axis will be inferred from the remaining dimensions. Give an example. Give me some reshape examples. Example. Give me examples that go from higher dimensions to lower dimensions. So 3D array to 2D array, 1D array. Okay, so it's like that. That'll just take. Okay, it just will take the last one, I guess. Let's see if that works. I think that should be fine. It takes the latest dimension. Yay! I think it's cool. I think it works. I think it works, bros. I think it works. Should I print input size? Can I print? Can I print input size? For these. I don't need the whole code. I don't need the whole code. Can I just use default? I think default works well most of the time. So yeah. Default really works well most of the times. And now put size this. Boom, boom, boom. Okay. Now we've got these. So I guess now we want to train it. So now we want to train these. Okay, so we got, okay, so we got 75 samples or input samples. Give me code to train NN. on 80% of these samples. Let's see. Let's see. Okay. So got now network. Now it's time to training. This, I mean, let's do it like this. So we'll keep these as like a, so that's just like a forward test. And now here we'll do the training. Training. So first, select the training data. Print. No, print. Train data. Shape. Let's do this. So, train data shape. 60 by 520. I like it. Okay. So and now here comes the interesting point, right? So never trained a thing in my life. Like, I'm not kidding. I never trained a thing in my life. Train another network for I range non-epochs, so that's not defined. Okay. So we can just define epochs. I guess this is hyperparams. Non-epochs is going to be 5, whatever. So for X in train data, so we go through each of these, then obviously we need to redo the reshape, right? So I guess X in train data, so it's going to be, you know, it's going to pick each of the 60 elements. We're going to reshape X. I want to, just in case, can we print X shape? Okay, print I, and print X shape, and then we do the forward, and then there's basically a backward path and the learning rate. What's it called? Learning rate initial value, I think it's like 0 on something. Learning rate. Okay. I don't know. Now what is Y? X and Y. So what is these, right? So but I still need, so how do I compute any loss, right? The backward stuff is learning rate. Okay, so this I'm missing, so I am missing some sort of loss function between the forward and the backward pass. Because I guess what the backwards pass is doing is updating those like weights, right? Yeah, that's the idea. It calculates here, whatever. This is what, like, yeah, you don't understand that, but I can understand how that works. It updates that. And it's also matrix multiplication. What is it doing? Loss function. Where's? Okay, yeah, that is the point. So Y is the actual output reference. That makes more sense. That makes more sense. That makes more sense. So got these forward pass. Then there's a loss function that I need to add. That is probably somewhere here. Where's loss function? Here. Define the loss function. Whatever that is, I don't know. I don't know. We can just have it here as a loss function. I I don't know. I really don't know. Is this gonna work? I have no idea. So I give that, then there's an output, then there's a loss function calculated between y and the output. Yeah, makes sense, right? So the output of whatever the forward pass gave you, and then you calculate what the loss is. But then what are you doing with this loss? Then this loss is not. So what are you doing with loss? Like, so what are you doing with loss? It's not doing anything with loss. What are we supposed to do with the loss? It's not passed to the backward pass at all. I guess it doesn't have to be. It's maybe something we just want to output. Maybe it's something, I think it's maybe just something we want to, so print loss. Print loss. So the loss is calculated, but it's not used acting by pass. Instead, it's used for analysis and monitoring. Exactly. Okay, that's true. I think the loss, you just use it as a way to monitor the performance, right? The backward pass just does, you don't do anything with the loss. The backward pass just does like the derivation and then just updates the values, right? This is automatically. I think so. Let's see. Does this work at all? So we are going to do another test here, right? Another forward test. Or then we should do an actual. Then we should just do an actual inference thing here. Not inference. I don't know if that's inference, but it's like we should just do like an actual forward test where we kind of we pass a sentence through the whole thing again, and well, let's just then kind of use one of the things to predict. So let's just use, we could use that again, forward. Yeah, we could use that again. So forward test here. Another forward test. We pick just the first, we just pick the first element. And then can I just, so print index with highest value of an NP array. Can I do that? You know what I mean? I want to print not edit code. I just want default. I think it's not doing this intent well. I've heard Amjad saying in the next space that like this, I think it is great. It's trying to pick up the intent from your sentence and then kind of select the modality up front, but it's not doing. Let's see. So we want to do max. Index like that, NP argmax. And then index. Can I just do that? Will that just work? Will this just work? I don't really think that if this is gonna work, but let's see. Okay. Mm. Okay, something's wrong with the so clean eye shape. X shape loss. Okay, so here it just basically says tuple index out of range and backward, right? I think backward is also assuming that X has shape 0. I think it's just X doesn't have a shape. I think it's just basically, isn't that just 1? Wouldn't that just work? And if not, we'll see. We don't have to really get it to work right now. You know, there are just no A2. A2. Where is A2? Self A2. Maybe that should really be self logits. Self logits. And that should just maybe be self logits. I don't know. If it doesn't work, we'll just stop it here, but at least we've done something. You know. Okay. I think can you rewrite these? Can you rewrite off the newest code in NumPy? I think yeah, it still does the same mistake, right? It's not working as I expected. So what is it failing? Where is it failing? So it's saying basically line 35 here, line dot shapes not align. Okay, we need to work on these. We need to work on the backward propagation. I'm not so sure that is easy. Yeah, I'm not so sure that works right away out of the box. But anyway, we've gotten to a point where we've somehow started the concept of the training here with its loss and then the backward stuff. Yeah. Let's see. Hopefully that works. See you next time.